Hello everybody, this is Jeff Janess and welcome to our fourth lab exercise on projections and datums. Now in this lab we're going to explore how to take a projected coordinate system and determine what the underlying geographic coordinate system is. And why would we want to do this? Remember that ArcGIS struggles when faced with data that come from different geographic coordinate systems. In this case, ArcGIS must perform some transformation to make the data line up correctly in the map. It also has to perform these transformations when you spatially analyze the data so that one dataset can be correctly compared or intersected with other datasets. Now the problem is that there are often multiple ways to transform data from different geographic coordinate systems so that they line up correctly, and ArcGIS often needs your help to pick one. ArcGIS Pro will often take a guess as to what's best, but the algorithm is not foolproof and you should know how to evaluate them yourself. And remember that transformations are only necessary when you're working with different geographic coordinate systems. It doesn't matter if your data are projected because the problem only lies with the underlying geographic coordinate system. So you should know how to find the underlying coordinate systems. Now, in this lab, we're going to look at several projected coordinate systems, and we're going to identify the underlying geographic coordinate system. And we can find this information in the Spatial Reference Properties window. This is available in lots of ArcGIS tools, but we're going to use the Map Properties window in this example. So we get there just by opening up the Map Properties as you've done before. Go into the Coordinate Systems tab, and then we're just going to search for the various projected coordinate systems. And from here we'll be able to find lots of information about the underlying geographic coordinate system. And in the lab exercise I show you an example just using the first projected coordinate system in the list. It's under projected arc, and this top one. Just hit details, and from here you can see that this projected coordinate system is projected from WGS 1984. It's also useful to know that the linear unit is in meters. Okay, so let's try it with those other projected coordinate systems I described at the beginning of the lab exercise. So we're going to try it first off in North American Albers Equal Area Conic. We can find it a couple of ways. We could search for it just by typing the name of it in here. I'll tell you though, that's sometimes unreliable, especially with the North America. I'm always typing North American instead of America, and it just can't find it. So if you do it right, there it is. I'm giving you these well-known ID values that are a little bit easier, so if you just copy that and paste it in here, it'll also find the same coordinate system. All right, so North America, Albers Equal Area Conic. Let's hit the details. We find that this is projected from North American datum of 1983. Linear unit, and this one is also in meters. Okay, so this is all good. Let's move on to the next one. Mall-wide. So mall-wide happens to have the well-known ID value of 54009, so I'm just going to copy that out. There's mall-wide. We hit details. So the projected coordinate system mall-wide is projected from WGS 84. Mall-wide also happens to be in meters. Oh, just in case you're curious, this where it says meters 1.0, that doesn't mean like this is the first version of meters. That means that that 1.0 is the transformation from whatever this linear unit is to meters. So meters to meters is a 1-to-1 conversion factor, so that's why it's 1.0. We get to this one down here, it'll be different. But anyway, let's do Egypt red belt now. Egypt red belt is 22992. Let's just pop that in there. Hit go. There it is. Egypt red belt is projected from the geographic coordinate system Egypt 1907. So something new here. Linear unit is also in meters. Okay, so that's fine. Next up, NAD 83 State Plane Arizona Central, FIPS 0202. Let's just copy that, so much easier. There it is. The details here. Okay, this one, not surprisingly, has NAD83 in the name, is also projected from NAD83. In this case, the linear unit is in feet. Now you see the 0.03048. That's how many feet there are. That's how many meters there are in a foot. So that is the linear unit and underlying geographic coordinate system of this particular coordinate system. All right. That's all there is to it. From that, you should understand that, say, if you had data in mall-wide, and mall-wide is projected from WGS84, and you wanted to do something with the other data that was in this coordinate system, and since that is in NAD83, that's when you face the problem. That's when you're going to have to declare a transformation that will line those two data sets up correctly. And just to be clear, the problem is not the projections. We don't care that one is mall-wide and one is state plane. The problem is purely about the underlying geographic coordinate systems, that one is in WGS84 and the other is in NAD83. All right, thanks so much.